Hey guys, this is Mr. Harbinger. I am delivering on my promise to complete the data modeling lesson. My son was born on Monday and he came home on Wednesday at the exact time we're supposed to have class. And although I really enjoy working with you guys, I was really excited to bring him home. So, doing this is going to be a recap of Algebra 1 in terms of linear regression and correlation coefficients. And then we're going to as we go through the summer, the next three classes after this, we're going to step it up a little bit and move into Algebra 2 stuff and really kind of conceptually explore some of the data modeling things we're going to do. I think you're going to enjoy it. This is just my Google Drive. Sorry, I didn't mean to leave that open. So we're going to do data basics. I'm going to upload this if it's not there already. Pretty sure it is. And I'm going to do my best to kind of go over some of the absolute basics of data modeling. And then we're going to handle how to do a regression. I normally would use a graphing calculator to do the regression, but I can't assume that everyone has a graphing calculator. Heck, I don't have one at home that I have accessible, so I try to use my favorite web-based free software. So I'm going to show you one of my favorite websites to do data modeling with. Here we go. So present mode, I might have to exit out of this a couple times, but that's just how it goes. So, hey, what's data? So I say data a lot, and I think everybody says it a lot. Even like my grandparents would say it a lot. Maybe they know what data is, or they talk about data plans or something. But it's one of those words you use all the time without really thinking about what it means. Data is information, though, and we collect that information in order to make some predictions. We look for some interactions between the information bits. It's not just zeros and ones, which a lot of people think data plan, or maybe they think data is only zeros and ones. They think in terms of computer science. Not always. Data can be as simple as what's your favorite ice cream flavor? So Harbinger likes, chocolate with peanut butter or something like that is a bit of information. That way, if you ask the rest of my family, you might look for a trend, or maybe I find out that some of you also like chocolate with peanut butter. Heck, some of you might even hate ice cream, but that's just data, right? So we deal with it. I had a formatting issue, so sorry that it looks like there's going to be a lot more stuff down here. There's not. We do collect data though, because we want to make some predictions. It doesn't really have a point if we collect all this data and then we do nothing with it. So we like to use the data in order to make predictions about what future trends might happen. People do this all the time. There are data scientists, big data, if you've ever heard those terms. Big data collects like millions and billions of data bits on people, maybe even more than that. And they try to make predictions about what they might do based on that. So maybe you're buying history on Amazon and they make a prediction about what you might want to buy next is definitely a prediction based on data collection. My car has learned that every Friday afternoon, between 4 and 5 o'clock, I'm going to go to the Cat Coalition, and my family and I, we volunteer there. So it suggests map options. It makes a prediction based on past data, time and GPS data. It probably knows where I'm going sometimes. If it's 11 o'clock at night, it knows I'm going to Wegmans because I'm a dad and that's just what we do. It also looks for relationships, though, in data. Sometimes I don't really want to make a prediction. I just want to know if two data points or data categories are related. So maybe we're going to look at some variable relationships. When we talk about variable relationships, I'm really talking about the correlation coefficient. So if you remember Algebra 1, you might have talked about correlation coefficient. And correlation coefficient really talks about the strength of the relationship between those two variables. And that ranges from -1 to 1, which really 1 really represents it is a 100% positive explanation. You can explain this number based on that number 100% of the time. We are really supremely confident that those two things are very, very, very strongly related. And it might be something as goofy as if I were to measure the length of your legs and then measure how tall you are. Your height is likely to be a function of your leg length. They are very positively correlated. The longer your legs are, in all likelihood, the taller you are. So that would be almost a 1. Something like 0 is they're not correlated at all, and we'll talk about that. And that could be something ridiculous. But Sometimes there's a negative relationship, and that doesn't mean that it's not strongly related. It just means as one goes up, the other goes down. So we'll talk about that in a second too. But correlation coefficient is the number we use to specify how strongly related two variables are. Usually the variable is called R when we talk about correlation coefficient. So if you remember the R value from Algebra 1, that's what this is. And because COVID's weird and school got weird, you might not have gotten into what R is, but we're definitely going to use R this summer. I don't mean the programming language R, I don't mean Dr. R. All of them are awesome, but R is also a correlation coefficient. And if you're thinking right now, why didn't they pick C for correlation coefficient? I don't know. I guess is the answer to that. Okay, so positive correlation. One goes up, the other goes down. So I have 4 cats at home, and we spend a good amount of money on pet food every month. Some people are like, well, what if you have more cats, but you spend less? You can make a dot plot or a scatter plot out of this. And that would be, maybe you buy pet food in bulk, and so, which is what we do at my house, but maybe you buy even larger bags and you spend a little bit more money total, but less per cat. Maybe somebody spends a lot of money on pet food and they only have 1 cat. They spoil the cat. The cat gets like filet mignon or something like that. I've seen people buy really expensive steak for their dogs. But at the same time, in general, because the point of data collection and prediction, the point of correlation is to talk about in general. In general, the more pets you have, the more pet food you buy, the more money you spend on the pet food. So that's a positive correlation. Another positive correlation would be like SAT scores and your average in high school. So there are people in Upward Bound who have a 100 average in high school and a 1500 something on their SATs. Really high average, really high score. There are people who don't do too well in school. They get like a 68 or something like that as an average. And maybe they do poorly on their SATs. So your GPA in high school is kind of a good indicator about how you're going to do in the SATs. And for the people that are thinking, wait, but what about the outliers? One of the smartest students I ever had an overall average in high school of 65. And he had a 1510 on his SATs. The guidance counselor thought that the software was broken. And he had to explain, no, I just didn't try very hard in high school. It's easy. When I hit college, I will crush it. And he did. He's had a 4.0 all through his master's program. He's now an anesthesiologist nurse. He makes a ton of money. But he's also super smart. But that's an outlier. In general, SAT scores and GPA are positively correlated because as one goes up, the other goes up. An opposite of that is a negative correlation. Now, that doesn't mean a bad thing. And it doesn't mean they're not correlated at all. It just means as one increases, the other decreases. So latitude and average temperature. If we had class, if it was live, we were going to do this one in class. And that was going to be, I was going to have people pick a city in the world somewhere. And we're also going to find their latitude in terms of their GPS and the average temperature. So Syracuse, I don't remember what our GPS is. I had this and I was pretty happy with how the activity was going to go. And then they released Owen home like a day earlier and I thought they would. But we have a latitude number, which is how high above the equator we are. And we have an average temperature of, whatever it is, like 60 degrees or something like that, Fahrenheit. But maybe you would have picked a different city. Cairo, Egypt is really close to the equator. It has a higher average temperature. And it has a latitude of like 3 degrees south or something, or 10 degrees south. I don't even know. But it has a very low latitude number and a very high temperature. Other cities are a middle of the road latitude and a middle of the road temperature. And then some cities have a very high latitude. They're very far up north or very far down south, like Antarctica. And they have a very low average temperature. So these are opposite related. If you're thinking right now, something like, Reykjavik, Iceland, kind of has a high latitude. It's pretty far up north. Something in like northern Russia, something really far south, like Tierra del Fuego in South America, is crazy far down there. It has a very low average temperature because they're kind of icy. So one goes up, the other goes down. That's a negative correlation. and then 0, they have nothing to do with each other, nothing at all. And I'm dying to make examples here, but sometimes they're related in ways you don't think. So I try to go number of tattoos and IQ. I'm not trying to generalize and say, oh, people with a lot of tattoos aren't that smart. Not true. I know a lot of really smart people with tattoos, and I know a lot of dumb people without tattoos. But so it's kind of all over the board. These two variables have nothing to do with each other. You know, you could have a lot of tattoos and be smart. You could have a lot of tattoos and be dumb. You could have a lot of tattoos and be somewhere in the middle. Same thing with IQ, going the other way. You know, smart people don't have a ton of tattoos or no tattoos. Like, it's just random. These variables have nothing to do with each other. Therefore, it's getting 0 correlation. So before we do the regression thing, it's kind of easy to show a scatter plot, which is exactly what I'm going to do. I'm going to go to my favorite graphing website, which is Desmos.com. And Desmos.com/calculator brings this up. So what I'm going to do right now is I'm going to add a table, and I'm going to show you some examples of positive correlation or negative correlation. In fact, I could just Google image search right now, like strong positive correlation. I love Google. So a strong positive correlation is like this one. I don't even know what the categories are, but you can tell that the dots are really close to a trend line, right? Like a line of best fit. Something like this guy over here. They're almost perfectly linear. That's very, very positive correlated. So that's got an R value of like 1. This also has a positive R value. You can see these guys are going up. Same thing with this one over here. It's a weak positive correlation. You know, maybe the R value is like 0.4 or something like that, 0.5. Sometimes they go down, right? This guy down here is a negative correlation. You can tell that the line, all the dots are linear, like they're almost in a perfect line. So that correlation would be like -1. Whereas these get progressively weaker. So maybe -0.5 and maybe -0.2 or something like that. We'll talk about how to calculate it here in a little bit. And then sometimes there's a 0 correlation. Like you see this guy here, no correlation. These dots are all over the place. So it's hard to make a prediction when there is no correlation. And if you're wondering about like funky looking graphs, like this thing, today I'm only assuming linearity, which means I'm only playing with scatter plots that make a straight line. We're going to do weird curves throughout the rest of the summer. Today is not that day. We're going to do straight lines. Anyway, Desmos. If you go to desmos.com/calculator, I'll start from scratch here. If you go to Desmos, I'm pretty sure I linked this in the Google Classroom assignment. But Desmos.com/calculator brings this up, right? You can graph stuff all you want. You can graph like y equals x squared or something like that. I'm not doing that right now. Instead, I would like to add a table. And so when we get to the types of regression, here's what we're going to do. We're trying very hard to make, what am I going to say here? Trying to make a trend line, a line of best fit. So in truth, it was originally going to be something like the latitude and the average temperature, but then it didn't happen. So this is kind of relevant to that, and maybe we'll do this next time as like a startup activity. So maybe for homework, people can come up with a city, find their GPS location, find their latitude, and also find their average high temperature or something like that. Anyway, add a table, enter the data. Sure. I'm going to make up bogus numbers because I didn't want to violate privacy and start looking up people's grades and their SAT scores and things like that. So let's assume someone's got an overall average of 99, and maybe their SAT score is like 1510, right? And then maybe somebody else has like a 98, and they probably had like a 1490, and maybe somebody barely passed high school and they've got like 1,000, and then maybe somebody kind of did better than that and like 1120 or something like that. Maybe somebody also got a 99, and maybe their line is a little bit higher than 1510. Maybe they got like a 1530. Right? It doesn't have to be like that all the time. So I'm going to throw in some other ones, 80, and maybe they got like 1200, and maybe there's Somebody with a 75 also got a 1200. This is an over exaggeration here. Maybe some people got like an 85 and they didn't do as well as they hoped. And then maybe somebody had like an 86 and maybe they did significantly better, like that or something. So I'm going to put in one more and then I'm going to graph these and we'll see how that goes. In fact, they're already graphed. I'm just really, really, really zoomed in and I don't see the dots yet. So last but not least, maybe somebody got like, I don't know, 92 and they scored a 1300. So these dots are already here on the graph. I'm just going to zoom out. And so the zoom features are right here. And you can see my dots, right? That's a nice dot plot. And so if I really want, I'm going to change my viewing window with the wrench. And so my x-axis is going to be these guys. So I'm only going to look from, let's see, my smallest is 65. So it's okay to look from, I don't know, 60 to 100. Perfectly acceptable. And then my y-axis, that's just my range. So the lowest it goes is 1100. So lowest goes is 1000. So I'm going to look from, let's say 900, because I want to see everything on the screen, all the way up to 1600, just because. So now you can see these purple dots, and that's kind of nice. As the average goes up, the SAT scores go up. So that's really nice. Let's do one more. Let's give somebody a 100 average. I'm going to have another 99. Because I'm just trying to keep everybody on the same exact form here. And let's give them trying to keep everybody on the screen nicely. 95, and let's give them like a 1450. I have these nice trend lines right here. So if you were to draw a line of best fit, it would come right through these dots. So now we have to go make that equation. I would like to make an equation because I really want to make predictions. Hey, if the person has a GPA of 73, what kind of score can they expect? That's actually a really viable question, and people want to know those kinds of things. So I'm going to go make a prediction equation. And this is how it looks. Y with a little subscript of 1. That means, hey, express this variable, express these numbers, tilde, not equal sign. Tilde means like approximate, right? Can we approximate some data, please? And if you know y equals mx plus b, I let m be the slope, and I let b be the y-intercept. I don't have to call it that, but I chose to. And x1 is happening. So down here in item number 2, y1, and you can't just, never mind. I was going to say you can't do y1, but it just popped up. X1 plus b. And so what it did was I'm not going to talk about how it works, but they're trying to find a line that goes through and minimizes the distances between these dots and that line. And this line fits the data the best. You can tell there's some dots above the line, there's some dots below the line, but this line does the best possible job out of all lines of explaining this data. Now you can tell some of the parameters. It's got a slope of 14 and it's got a y-intercept of 74.63. We talked about R a second ago. R, in this case, we don't care about R squared. It's called variance. R for us is 0.90. That means this data is very strongly explained. It's 90% explained by this equation. That's really cool. Like that's a really good explanation in terms of how these two variables are related. It means it's not exactly 90% sure, but let's just say I'm 90% sure that someone's SAT score is like a really good approximation based on their GPA. So what I'm going to do now is I'm going to talk about what the variables mean, and then I'm going to stop talking. Slope means, slope of 14 means for every higher point I get on my GPA, I can expect 14 points more on my SATs. So if you're working hard to get from an 85 to an 86, you can expect that hard work to translate to an extra 14 points in your SATs. So when Ms. Haswell is hassling you for make sure you've got your work in, and Mr. Black is coming down on you guys for like, homework is important, make sure you study. I've heard that speech from him a lot. We here at Upward Bound really believe in people working hard to do their homework because it develops a seriousness of the mind. It develops good study skills and a work ethic. And that translates to things like SATs, which translates to great colleges and unlocking the future you want. How about that for the teacher speech? But anyway, so in general, 1 point higher in your GPA usually means about 14 points higher on your SATs. So if you can bump up from an 80 to a 90, which is a big jump up, but if you can jump from an 80 to a 90 for your GPA, expect 140 points jump on your SATs. That's really big. Also, a y-intercept of 74.63, which means if your GPA is a 0, you can expect a 75 in the SATs. And you can put your name on it and you have like a 700 or something like that. So it's not always a perfect fit, but that's kind of a funny thing. So what I'm going to do is I'm going to use my equation to approximate. I'm just going to round. Sometimes we round to the nearest integer. Sometimes we get a little bit more precise. If you saw the blue line, it perfectly overlays the red. And if you want, we can zoom in. It's not exactly the same. You can tell they're off by a little bit, and they're off by a little bit because I rounded. Right? This is 14.02. This is 14. This is 74.63. This is 75. That's why they're off by a little bit, but in general, I can use that graph to make a prediction. So what happens if someone's overall GPA is like 82 and a half? Well, they can expect a 1230 on their SATs. And if I want something more precise, I can use more decimals. But for now, hey, if your GPA is an 82 and a half, expect a 1230. It's actually a pretty good score. But then again, I just made these numbers up, so what do I know? So sometimes we can do something fun, like if you know your SAT score, you can kind of guess someone's GPA, which is fun, but it's not always about SATs and GPAs. There are other linearly related data sets out there in the world. I was going to have people measure around their head and how tall they are, because you assume that people with larger heads are just bigger people in general. That's a fun positive correlation. There are other negative ones, but I'm going to do one for homework here soon. And then after that, we're going to have some labs for the next couple of weeks, and I'm going to make sure I drop things off in the upward bound office so people have materials to work with. Homework. There's a Padlet assignment on Classroom. So what it is there is a Padlet assignment in which we talked about correlation. I did a category for positive correlation, a category for negative correlation, and I did a category for zero correlation. Please put an example for each. It can be a picture, it can be a description, it could be like, show me that you understand a positive correlation, show me you understand a negative correlation, and show me you understand a zero correlation. And because Padlet's a little bit weird with tracking who did what, can you put a name on your post, please, and tell me like, hey, my name is, M. Harbinger. This is my post, or something like that. That way I know to whom to give credit. Someone already worked ahead and I took their stuff off, not because I did a bad job, but because just we didn't get a chance yet to go over this together. And I really appreciate people working and trying to get stuff in. Thanks. I haven't made the Google form yet, so watch for that, but I'm going to collect some information from you. I'm not trying to violate privacy. I'm not being nosy, but sometimes I just want to use the data on the form to do some of these so I have a little bit more accurate numbers. I don't really plan on asking you about what your grade is in high school, but I might ask like, stupid stuff that aren't related. Anyway, and if it's getting kind of nosy, I might just delete it and do something else. So you have one more thing of homework, which is spelled wrong, but and let's do this just because I need to specify. Let's see what it tells us. So if you were to Google something like Syracuse, New York, attitude, I'll spell it wrong so I know Google can figure it out. We're at 43. We are 43 degrees above the equator. So that's kind of nice. And then I could also do Syracuse, New York, average temp. I don't want by month. I don't know. That one? Yeah, I don't want by month. Here we go. Annual high temperature is 58 degrees Fahrenheit. So you can convert it to Celsius. Let's just do Fahrenheit because as long as it's coming up on the internet like that. Although I prefer Fahrenheit, it's a little bit more, it makes sense. You know, the rest of the world likes, sorry, I prefer Celsius. It makes a little bit more sense. The rest of the world likes Celsius as well, as long as the website is coming up with average high temperature, then 58. So my data point would have been 43 and 58. Can you please next time have a city's latitude and average high temperature? If you do that, you can always look up other stuff, other data on usclimatedata.com. Pretty sure it's going to handle the rest of the world too. You know what? Let's look up a location just so we know. How about Paris, France? Or not? Ooh, it only does the United States. Ooh. Okay, I guess it's just US. So you can still look it up online. Like, hey, what about Mogadishu, Somalia? Which I can spell. Mogadishu, Somalia, latitude. 2. It's 2 degrees north of the equator. 2. That is crazy. And average high temp. Average temperature in Somalia is 80.7 degrees Fahrenheit. So in general, it's 81 degrees Fahrenheit and 2. So that's a really fun data point. 2, comma, 80.7. That shows you that Syracuse is further north and we have a lower temp on average. That makes a lot of sense. Do the same, please. Come prepared with a latitude and come prepared with the average high temp. Be looking, please, for the email or the remind saying that you have a regression kit available at the Upward Bound office. I'm trying to put them together this weekend and dropping them off on Monday if I can. You don't need it for Wednesday, but depending on what we get to and talk about, I'm definitely trying to give you guys things that we can work with. That way, I can't assume, like if I did this in my classroom or if I did this at Upward Bound, you know, at Lemoyne campus, I'd have things for you. I don't really have that right here, so I'm going to try to get it in your hands between now and when we do it. So be looking for that too. So again, if I put a Google form up because I'm feeling industrious and I'm trying to think of questions that don't make me nosy, hey, watch for the form. If it's not up, that means that I realized my questions were too nosy and I'm getting too invasive. If you look up a city, please make sure you remember the latitude and the average temp. Other than that, I will see you guys next Wednesday, and we're going to do a regression equation or two together, along with some other kinds of data models. Hope everything's going great. Peace.